Thank you and welcome everybody to the third day of our workshop on demand-side data and energy efficiency indicators for the Southeast Asia region. This workshop is organized by the International Energy Agency in collaboration also with our Regional Cooperation Center based in Singapore, represented here by Natalie. My name is Roberta Quadrelli. I am working in the Energy Data Center of the International Energy Agency, and we are also very pleased to work in collaboration with APEC, our colleagues of the Asia Pacific Economic Commission, long-standing collaboration on data for the IEA. This is the third day, and we looked at different sectors. First day was industry, second was buildings, and today we look at transport, which is very important in the region. All the workshop is about demand-side data because demand-side data are very important to drive the energy requirements for each country. Definitely if we look at, for example, at planning, at climate targets, policy, we need to understand the sectoral and subsectoral trends. Clearly, one major application is the energy efficiency policies in each sector, where the policies and measures are very targeted, and we look at that. Southeast Asia is certainly a very important region, growing very rapidly, different energy supply, energy patterns, but also common high ambition in energy objectives. So clearly, it's an important opportunity for us to engage with all of you and see also hopefully a longer-term collaboration with the International Energy Agency. I would like now to invite Natalie from the Regional Cooperation Center to give some opening remarks. Thank you.
Thank you very much, Roberta, and thank you everyone for joining for what is now the third day of this training. Today we'll be focusing on transport. So my name is Natalie Kauf, and I am an analyst in the IEA's newly opened Regional Cooperation Center based here in Singapore, where we are focusing on Southeast Asia and the region. I've been at the IEA since 2022, and I've had the opportunity to work with Southeast Asia for the last couple of years, and now to be able to be based in the region. In this new office, we're hoping to find other opportunities where we can collaborate more bilaterally and regionally, especially with you, with people, policymakers, in Southeast Asia. So I see a lot of names on the list here that I recognize that are some of our key partners, and we're really grateful that you're here today and you've joined us, especially if you joined for the other 2 days. That's great news. And we look forward to finding other opportunities to engage with you. I'll put the Regional Cooperation Center's email in the chat below, and afterwards we'd be happy to engage with anyone if you want to continue to collaborate on data, energy efficiency, or any other energy topic in the region. Thank you. So back to you, Roberta.
Thank you very much. And I think we can start. Natalie, actually, I would like to give you the floor for chairing today. So please go ahead to introduce all the other speakers. We have a nice selection of panelists from different backgrounds and different countries. So wishing a very fruitful discussion today and a longer term collaboration on this topic. Thank you.
Thank you, Roberta. And so first off, we'll have a presentation to set the scene from Renee Stevens, who is the IEA's expert on energy efficiency in Southeast Asia. Thank you, Renee.
Thank you, everybody. And thank you, especially Natalie and Roberta for the kind introductions. I'll get started with sharing my presentation. Now, if you are... sorry, I need to...
Thank you, Renee. If you could put it in presentation mode.
Yeah. Now, are you seeing the right... Nope, you're not.
I think just flip it
over. Thank you very much. It's always back to front, isn't it? I'm not sure if other people have this same situation, but mine plays tricks on me. Here we go. Okay, I think we're ready. Does that look right now, everyone?
Perfect. Thank you.
Okay, thank you very much. So thanks everybody for your participation again today. I have the pleasure again introducing the discussion today, focusing on the transport sector. So we'll learn about what demand-side data and energy efficiency indicators mean for the transport sector and really how they can help for policymaking around transport. And so, as always, let's begin with some contextual information to find out a little bit about the big picture of energy consumption in Southeast Asia today. So, in Southeast Asia, looking at the transport sector, we see that oil meets around 90% of Southeast Asia's energy demand, and this is in line with the global average. There is change underway, though. The region is becoming a new centre of electric vehicle growth. So last year in Southeast Asia, electric car sales grew by nearly 50% to represent 9% of all car sales in the region. Thailand and Vietnam had notably higher sales shares. And IEA modelling sees electricity and modern bioenergy being increasingly used to meet demand in the coming decades. So the IEA's modelling of the region's energy demand out to 2050 sees that this demand is growing, and increasing incomes, higher rates of urbanisation, and somewhat limited public transport options are the factors that would lead to rising ownership levels of cars and 2-3-wheelers in Southeast Asia, ultimately driving up energy demand in the transport sector. So with the transport sector growing and undertaking change, it will be really important for countries to be looking at the data to understand the changing situation, the problems and the opportunities for supporting the energy transition in the sector in the region. So this will be familiar to many of you who've joined us the last 1 or 2 days. So here we are with the definition, once again, energy consumption and activity data are what we're talking about when it comes to demand side data. And the data is grouped. And so for the transport sector, we would be looking at grouping passenger related transport and freight related transport. And, you know, in the higher down, the more fine grade level, we can be grouping the data according to different types of transport modes. And energy consumption data is typically the per annum consumption by fuel type. And depending on the sector, the units that we use will vary, and depending on the technology. And it covers activity data is covering a wide range of activities. So there's different ways that we can look at activity and seek to define that. Maybe we'll look at population and what's happening with the transport trends, with population trends. Sometimes we'll look at passenger ton kilometres travelled or ton kilometre travelled. They can be typical metrics. And so energy efficiency indicators are this ratio that's representing the energy consumption per unit of activity of the given category. And the energy efficiency indicators enable us to identify the energy efficiency status quo, describe changes, and provide evidence for policy making. And the most generic indicator we'd use is energy intensity. And energy efficiency indicators allow us to collect and analyse data on a consistent basis over time. And this concept applies at different scales. So we can look at the energy efficiency of the transport sector on an overall sectoral basis, or on the basis of passenger and freight transport according to road, rail, air and water, or on a really granular level according to each type of transport mode. We might be really interested in the Southeast Asia region, in 2-3-wheelers, passenger vehicles, freight transport, buses, etc. So collecting transport energy data and using consistent energy efficiency indicators is really valuable for supporting policy making at different levels, from the macro to the specific. And so how can transport sector demand side data and energy efficiency indicators be useful for policymakers? So we can use these to identify the current situation, trends, highlight problems and opportunities. And so we can be looking at new policies, updating policies, strengthening policies. We can be using the data to build our business cases and look at our cost benefits of introducing new policies. It can be really important for that. And it can be really useful for monitoring what's happened in the past, where are we today, and for coming forward with some projections for what might be happening in the future. It can help us to identify progress, evaluate success of policy interventions or programs. And then for refinements, it can be used for updating policies, ensure that they're calibrated really effectively, and that our targets and objectives are in line with the status quo that we are seeing at the moment. So at the highest level, of course, we are tracking global energy efficiency progress. The IEA's Energy Efficiency Progress Tracker is a tool that we can use to look at how we are tracking globally, regionally, and on a country-by-country basis in terms of energy efficiency progress. And this is the very highest level example, really, of how demand-side data and energy efficiency indicators can culminate in useful information that we can then utilize to be forward-thinking with where we go next and what needs to happen next in terms of our energy efficiency policy. So some examples here to illustrate, I think, how data can be useful for policymaking. So Japan has implemented transport energy efficiency policies over a long period of time. And this snapshot of information here shows the difference in energy demand in the transport sector in 2010 compared with 2019. And what the data identifies is that although there was more activity, distance travelled in 2019 compared to 2010, the energy efficiency gains were so significant that they offset that increased activity and then some. So the net result is that we see quite a large reduction in the total petajoules of energy demand in the sector. And this example, I think, is helpful for illustrating the value in tracking energy demand to see how demand is shifting, and also the value in collecting enough granular information and data that enables some more fine-tuned analysis. So in this instance, energy data underwent decomposition analysis, and that enables a clearer understanding of what occurred beyond the change in energy consumption. And through this process, we learn how energy efficiency improvements, activity changes, or structural changes affected overall energy consumption. So the more detailed and fine-tuned the data collection, the greater insight we can have on energy relevant trends that we seek to understand. And as Natalie mentioned, this is a space where the IEA can really help with looking at data. When we have data available, we can be looking at some more fine-tuned analysis for different countries. Pardon me. And now just a quick final example, a little bit different, but I think it will give a lead-in and a taster of what we will hear in our country presentation. So this here we see data on the increase in electric vehicle sales over just 4 years, which is really quite dramatic. So policy interventions in India had an important role to play in this acceleration of EV uptake. India has and had also a range of policies that support the increased adoption of a wide range of electric vehicles. And so as we see here, electrification in road transport has so far largely come from 2- and 3-wheelers. A really important issue for the Southeast Asia region is the use of 2- and 3-wheelers and a great opportunity in terms of electrification. And so with India, their impact was evident in the fact that there was a 40% increase in EV sales in the month prior to its closure. So although this isn't directly looking at energy consumption, I hope it gives a sense of the usefulness of using data and different types of data to support policymaking and to track its impact. So stay tuned to hear more about that in our country presentation later in the session. And before I officially hand back to the chair, I would just like to mention that the IEA has an energy efficiency policy training week that's coming up in Southeast Asia in December this year. We're planning to have it in Hanoi in Vietnam. It will offer 5 different courses, one of which will be transport, also buildings, industry, appliances, and a data-focused course called Indicators and Evaluation. So that allows a really deep dive into energy efficiency policy making and an exchange of knowledge with others in the region on data and how it is useful for policy making in the world of energy efficiency. So we'll be sure to include you in any mailing list that we put together for that. And thank you very much. I'll hand it back to you, Natalie, as I stop sharing my screen.
Thank you, Renee.
It takes a little while. There we go.
That's all right. Thank you, Renee. That was great insight. And I think that's also great to bring up the Energy Efficiency Policy Training Week. So some of you may have had the opportunity to attend before, either in the region or in Paris. And really, this is a huge opportunity to spend 4 days going through with IEA and other expert trainers on a specific topic. And transport will be one of them. So those of you who are really interested in that, as well as indicators and evaluation. And even if you've had the opportunity to attend before, you can apply again and you can do a different course because they are all quite separate. And there will be opportunities potentially for nominations for participants to join as well. So we look forward to that. And now we're moving a little bit more into the more technical side of looking at the energy data. And here we have Thomas with us online, who's an expert from the IEA's energy data team. So over to you, Thomas, to take it forward. Thank you.
Sorry. Hello, everyone. Thank you all for joining this afternoon with us for this training to discuss the demand-side data in the transport sector. I'm Thomas Elgozi, and I work in the team responsible for energy demand data and efficiency indicators here at the IEA. So we have just slightly above an hour for this session, and I would like to cover the following topics. First, we'll talk about the importance of collecting energy data for transport. Next, I will remind overall why end-use data are important. After that, we will look at transport classification into segments, modes, and vehicle types, and what we can learn first from transport mode data only, and then from more detailed data. Next, we will go over the energy efficiency indicators for the transport and how to build them, what they mean. And I will conclude with describing methods of collecting data and the IEA tools for data capacity development. To make this session a bit more interactive, we will be using Mentimeter again today to ask you some questions, get your inputs, and start the discussion. So let's start with the importance of robust energy data for transport. Transport, as René said, is a key sector as much as arteries and veins are to blooded animals. It concerns all aspects of the economy and our lives, carrying people and goods around to and from industry production sites, offices, shops, waste centers, entertainment centers, and so on. And it contributes to much of the economy by bringing in consumers and products to the same place, be it groceries from rural to urban areas, parts from factories to other factories, kids to schools, parents to fields, factories, and offices, and so on. It is also recognized by the United Nations 2030 Agenda on Sustainable Development through multiple indicators, such as SDG 9 and SDG 11, which both include data on infrastructure and freight volumes. Finally, as you can see from this slide, and as we will see later on, it represents a large proportion of the energy consumption everywhere and a large source of potential efficiency gains. As René said as well, the transport sector is the second largest source of energy demand, accounting for a third of total energy consumption from end-use sectors, or around 6 exajoules per year. It is expected to grow from both passenger and freight transport and grow quite fast compared to some other sectors. And it's expected to grow also from all the 4 modes at different speed depending on the different scenarios. So as I mentioned before, we'll use the Mentimeter to get your participation. If you weren't here yesterday or the day before, or if you didn't manage it then, you should be able to use Mentimeter through the web, connected on menti.com, or using the application on your phone. I'll switch to the Menti, so hopefully you'll be able to answer this first question. This is just to make sure that everybody is able to connect. Again, the name of your institution is also because compared to other days, we might have some people from ministries of transport or other institutions which might be specialized on the transport data, the transport energy, and the policy making for transport. Just waiting a couple of minutes to see the numbers grow. Okay, so we have people from a variety of countries and regional institution, regional bodies. Great to see some ministries specialized on transport from Cambodia. Just waiting a couple more minutes to have everybody have the time to enter the code. The code is reminded at the top. Okay, I think you'll be able to answer this question anyway if you join on the way. Hopefully you don't have any issue connecting. Feel free to send a message on the chat if you do. Okay, the next question, we're diving into the transport. So how much does oil product represent in the transport energy consumption in the world, in your opinion? So we have various answers, 80%, 90%, 95%, or 99%. We all know that oil products represents by far the largest share in the transport energy consumption in the world. But you would apply different policies depending on whether it's very, very close to 100 or a bit lower. Okay, so far most people think it's closer to 95%. Very few people on the two ends, 80 or 99%. And hopefully you'll get the answer through this presentation today. Just one more second. Yeah, okay, 95% seems to be the winner. We'll get the answer in a minute. Another question, apart from oil products, great to talk about oil products, but other products are emerging or are legacies from older systems. Apart from oil products, what energy products are mostly consumed in the transport sector? Now I'd like you to focus on maybe on your country, because it depends a lot on countries, depending on the policies, on the historical policies and infrastructure that was in place. So it's interesting to see what you think would be other important products in your country. We see electricity first. It's obviously something that is increasing in many, many places and also in different modes, whether rail or road transport, obviously a bit less for air and water transport. Biofuels and wastes are also increasing, as well as gas. Coal is often a legacy. I'd be interested to hear about people mentioning heat. Feel free to send examples and information you have on this in the chat. That's always a bit niche, but interesting to see that. I don't know if you've been influenced by the image that I put here, but electricity is clearly a winner. We'll discuss quickly at some point how to integrate biofuels in the methodology. Okay, great. I'll switch back to the presentation. In any case, you can answer the questions as we go. So let's look at now why end-use data are important. As we said, first of all, obviously, by providing detailed insights into energy consumption, demand-side data enables policymakers, researchers, industry stakeholders to make informed decisions and track progress, but also to implement new effective strategies. By revealing shifts in usage patterns, this data also helps assessing the impact of the policies, of technology deployment, and of consumer behavior over time. Reliable demand-side data also enables bottom-up modeling work, allowing more accurate projections for future energy needs and a robust assessment of energy transitions. Detailed demand-side data coupled with activity data enables the development of energy efficiency indicators that track the energy efficiency progress and measures improvement over time. Improvement of energy efficiency reduces the need for energy, reducing the energy cost and increasing the competitiveness and the profits. It might also have impacts on the environment, the negative output of energy consuming. Detailed indicators can help identify areas for energy reduction within their production process. These indicators can be used for assessing, setting, and monitoring policy targets, as Renee also presented today. Thanks to all this data, one can, for instance, decompose the energy consumption trend into the drivers and isolate the variations in energy efficiency from other factors which impact the energy consumption, such as the modal structure or the transport activity. So here, a quick note, I used the Australian data. This actually comes from the fact that we're lacking a lot of the detailed data, complete data sets from Asian countries. And you will see in the rest of the presentation that this is often the case. So here in Australia, we see on the left that efficiency allowed to compensate a significant part of activity growth for passenger transport. That is, the PKM in light blue increased significantly faster than the energy consumption in thick orange. On the other hand, for freight transport on the right, efficiency gains were less important, and the structural shift is what leads the biggest decoupling of energy and activity. This is key to track the impact of the policies, for instance. And here are the results for this decomposition analysis shown for the whole Australian economy over the past 2 decades. Total final energy consumption in Australia in 2022 was just above 3,000 petajoules, with savings, quantitative savings, over 400 petajoules. It highlights how much energy has been saved only thanks to efficiency improvements. And here in Australia, these gains mostly came from passenger and freight transport, on par with the industry ones. Let's look now at the classification of segments, modes, vehicle types, and energy products. So as we saw previously, a country's overall energy situation can be represented as an energy balance. It has a good name because it's really the balance between the supply and the final consumption, taking into account the middle block, which is the transformation. In the columns, you have the energy products, and in the rows, the different flows. It can be detailed as much as you want, pretty much. It is great because you can sum up all the information in one table and easily compare the products because they're all reported with the same energy unit. And again, we'll focus today on the demand side, which is here in green. And here you can see a chart showing the total final consumption and how it decomposes. We'll be interested today in the transport, which can be split either first between passenger and freight, or first between the different modes here, which are below the passenger and freight, so road, rail, air, and water transport. And then into vehicle types. So then again, some of these segments cross-mode split require further detail, The most important in size and policy tracking is passenger road transport, which is why it's often the one which is the most decomposed between what I will call in the rest of the presentation cars, but it's actually cars, SUVs, and personal light trucks. Motorcycles, which actually covers motorcycles and all the 2-3-wheelers which are engined, and buses or coaches. Depending on the priorities, other can also be split further, looking at passenger trains by typology, freight road by load capacity, or even you can go further in passenger cars or motorcycles, dividing by vehicle class. I would like to point out a few exclusions from the transport sector in this methodology, as well as some points of attention. So first of all, note that pipeline and gas pipelines transport is excluded from our methodology. An important question is the international or multinational transport, as we adopt here a domestic perspective that is a territorial approach and not a national one. Thus, we exclude fuel that is consumed in international airspace or in international water. They are both accounted for in the international bunker in the balances. So in the demand side, in the supply side, sorry. But it's also for cases where fuel is loaded in one country and then maybe the vehicle crossed the border, like diesel in a truck that would cross the border and would be accounted for on the other side because we're looking really at the domestic perspective. Another point of attention is what I call misallocation. It might happen due to the way the data is often collected. The most important ones occur for typical transport fuels like diesel being used for other activities. It can be tractors in agriculture, it can be diggers in construction, it can be mobile electricity generators, whether in residential or industry settings. This can be identified, for instance, from reporting from other sectors and then used to estimate the necessary corrections in the transport reporting. That happens as well in case of home charging, because obviously the electricity is taken from the same bill in the residential setting and then has to be transferred in the transport side of the consumption. And one last caveat, which depends a lot on the countries, refers to informal trade, for which more and more estimating tools are available when needed, such as crowdsourcing. Beyond the split in end-use or vehicle types, one would want to collect the data split by energy products. As I said, as the transport sector is mostly dependent on oil products, further detail that in other sectors are needed. Typically, reporting and questionnaires list at least motor gasoline, diesel, LPG, heavy fuel oil, and jet fuel, but also some details can be provided if need be. So once more, let's play a bit with questions on Menti. So hopefully you've had the time to answer this one. So now in the energy demand in transport considered a key focus in your country's energy strategy. Is your country focusing mostly on passenger, mostly on freight, on both, or on none of them because it's not the priority at the moment? Glad to see there's actually one answer at least on both segments. And so far, no one says none. Okay, it's interesting to see that so far nobody says freight mostly. I would have guessed a bit more. Okay, it seems definitely nobody wants to look at the freight segment only. Excellent. Let's move on to the next question. Where would you report the diesel boat to refuel a truck in Thailand that would travel mostly in Cambodia to carry goods in Vietnam? Okay, so had it been maybe a ship that would go through international waters and go from one to directly from Thailand to Vietnam, it would have been in international consumption, in international bunkers. In this case, several answers were possible. Most of the consumption would probably be in Cambodia because that's where most of the travel occurs. But in real life, what often happens is that this is very hard to know exactly where it would go because most of the data would probably come from gas stations where the truck has refueled. So the information will probably end up in real life in Thailand's energy consumption, even though theoretically what would be ideal is that it would be mostly in Cambodia, a tiny bit in Thailand, and a tiny bit in Vietnam, proportional to the where the consumption occurred territorially. So very interesting to see that this is a very difficult topic, both methodologically and in practice, and how to collect the data. And sorry, that was a question for the next one. I'll switch back to the presentation, but in case you can answer in the meantime. So let's quickly look at the energy balances and what we can learn from it at this level. So the energy balances typically focus on the transportation modes. So here you can see I switched the tree showing the modes first and the segment in second step because the energy balances focus on that. Still, we can get some very interesting insights from there, and we'll see which ones. So first, as we said the other day, industry is the largest sector globally, almost on par with transport. In 2002, according to IEA data, transport was second in the final energy consumption and consumed more than a quarter of final energy, almost as much as energy. When we look at the Asian region, the share of transport is slightly higher, but it's clearly second to industry, which is larger at 37% of TFC. But transport remains significantly above total buildings, which is 21%, and almost double that of the residential only. At the country level, the prevalence of transport varies significantly in the Asian region, from 12% in Singapore to 35% in Indonesia. And we see that it is more evenly spread than other sectors in the region. And it's closer to the world average for almost all countries. Singapore probably be a bit of an outlier due to its geography. If we look at the product mix, as we expected, again, oil represents by far the largest share. It's around 90%, so close to 95, but closer to 90 still. And the share of biofuel and waste product is significantly larger in Asian countries, taking up shares from natural gas and electricity that we see in the world split a bit more. Still, we can dig a bit further, splitting the Asian consumption into the four main modes and detailed oil products. First, on the left, we see that the oil products are mostly split between two products, actually, which is gasoline and diesel. In this chart, note that the biofuels are included in each of the products. So gasoline is gasoline plus biogasoline and so on. And so these two products, gasoline and diesel, represent about 94% of the consumption. Jet fuel represents about 2/3 of the remainder. And this is obviously very strongly correlated with the dominance of road transport within the total, since 92% is consumed by cars, motorcycles, bus, and trucks, which are almost only fueled by gasoline and diesel. Rail and water transport may also consume diesel, increasing once more this dominance. So let's go a bit deeper and look at the vehicle type data. So what about the split between passenger and freight, as we said? That is how much is consumed by cars and two-wheeler, two, three-wheelers on one side and trucks on the other. What is the most used passenger transport between trains, buses, and cars? And what is the typical distance covered depending on the vehicle type? Similarly, we want to ask in the freight segment, what is the load factor depending on the different modes? Then we could be interested in what fuels are mostly used in each vehicle type, and especially which fuels are developing beyond gasoline and diesel, and also how differ, obviously, from other countries or economies which are similar in the region. So to start with, as road transport takes up such a large share of total transport energy consumption, it is the part that one wants to split further here. So I have the data for the Republic of Korea for 2022, where road transport consumes 95% of the energy, and it can be split into passenger cars for half of the total transport consumption, and then trucks, which is over a quarter. Then we have a significant part for buses, and in the case of Korea, a small part for motorcycles. This breaks down still into larger pieces, but already it allows to disentangle freight from passenger and private from collective passenger road transport. It allows a lot of insight for policy making, sorry. Interestingly, looking at the fuel split, one can also see the influence of various policies, especially for the share of gasoline versus diesel in the passenger cars and the prevalence of these two fuels with respect to other ones such as LPGs or electricity. In Korea, about 50% of the energy consumed from cars is gasoline, diesel is about 40%, and LPG only around 7%. Electricity seems to be just emerging. For buses, the diesel is only half of the consumption, which is interesting. It means that there's probably strong policies to push for gas and LPG, while we see that for trucks, that might be less of a priority in the country as they consume virtually only diesel. To go a bit further, we need to use the segment split for all of the modes, in addition to the road split by segment and vehicle type. Here we have the consumption of Japan for 2022, splitting first by segment, which is almost 2/3 and a bit more than 1/3 for freight. And then by mode and vehicle type, with passenger cars just above half of the total transport consumption again, and freight trucks almost exactly a third. Note that this is it's interesting, the respective weight of these two largest consuming vehicle types as they're summing up to 85% of the total. It leads to consider further split, maybe cars into cars only versus SUVs and personal light trucks, or freight trucks into the light commercial vehicles, the medium trucks, and the heavy trucks. Finally, we see also that beyond these two main vehicle types, passenger transport mostly consumes energy for air travel, and then trains, and then buses, while the freight transport mostly consumes energy for ships. Let's get a few more questions here. So I see some of you answer. What is the most used oil product in transport sector in the world? Give you a few more seconds maybe to answer this one. Sorry. Give you a few more seconds. Okay. And then we would like to think about what is the largest consuming vehicle type in the transport sector in the world, between passenger cars, freight trucks, airplanes, or trains. This one should be easy enough. Okay, so we see a clear dominance of passenger cars in the answers. One answer for freight trucks, two for airplanes. It's interesting. Airplanes are often considered as a very big problem globally. And it is true that in the data that I showed, international air travel and international water travel are not accounted. But despite this, passenger cars are definitely the biggest one in the world. And which mode beyond road is the most consuming in your country? So here we're interested in what you think is the most important to focus on in your country, knowing that road will definitely take most of the policy attention and most of the probably most of the data tracking capability. Obviously, the prevalence of domestic passenger aviation in your concern or in the consumption depends vastly on the size of the country. I would imagine it is less of a problem for very small countries like Singapore. Beyond this, I see domestic passenger navigation can be interesting for countries which have either large inland waterways or a lot of islands, many examples in this region, as well as passenger rail. Freight is again not the biggest concern I see. Freight rail maybe. Great way to carry a lot of goods with low intensity. We'll see that a bit later. Okay, thank you all. So let's look now at what additional data are needed to understand the drivers of energy consumption. As we said earlier, energy efficiency indicators enable us to track the changes in energy efficiency. Generally, energy efficiency indicators are intensities, which are presented as a ratio between energy consumption and activity data. And the basis of the IEA methodology, as we saw several times, is this pyramid where we have at the top very aggregated indicators, and the closer you are to the bottom, the wider the data requirement. But at the same time, the more interesting the data indicators will be to track the specificities of your country and the biggest policy priorities. In the transport sectors, vehicle stock, vehicle kilometers, and passenger kilometers or ton kilometers provide insight in themselves. When you use them, you can derive the load factor or the annual mileage of your fleet. Combined with energy consumption into intensities, they provide a variety of information too. One could disaggregate modes further depending on the priorities. For instance, water transport between maritime and inland waterways, or passenger rail between metro and light rail versus intercity rail. Importantly, the boundaries need to be very much the same between the activity and the energy so that you produce meaningful indicators. So we saw this several times. We have the split between segments and the split between the different modes, and you can go further in the split of the road transport, for instance. And the activity data, we have the vehicle stock, which is often derived from the registries, for instance. We have the load factor, which we're going to use to combine with the vehicle kilometer, the distance travel, and we have the occupancy in the passenger segment. So as I said, you take the vehicle stock and distance travel, you multiply them, and you have the vehicle kilometers. And if you multiply this by the occupancy or the load factor, you get the appropriate appropriate activity data for passenger segment and freight segment. So if we look at the activity itself, we have here an example comparing two countries, and we see that cars amount for a similar share of passenger activity in Japan and Chile, while the remaining part is mostly trains in Japan and mostly buses in Chile. So this might explain consumption patterns or show differences in efficiency, in energy security, in infrastructure, and even in habits for the population. The same data would be needed for the freight segment to have a closer look as well. So as we said, multiple indicators can be built. First, the non-energy indicators can be interesting. As I said, the annual mileage or the load factor, they allow to track, for instance, the use of bus lines or train lines over time, or the impact of shorter delivery delays on freight truckloads, for instance. Then, most importantly for us, the energy indicators, which can be either energy per VKM or energy per PKM or TKM, for depending on the segment. The first one provides a measure of the efficiency of the vehicle itself. It's equivalent to a fuel efficiency in liters per 100 kilometers, and it is often related to the vintage of your vehicle fleet. The second one is an actual measure of the intensity of the selected part of the transport sector. It takes into account the complete sector setup, from the number of kilometer people or goods travel to the vehicle efficiency of the chosen mode, from the load factor to behavioral impact. So this intensity per PKM or TKM is the most complete and valuable indicator, especially when you have also information to disentangle the different drivers in there. If we look at the intensity for the two countries I mentioned before, Chile and Japan, we know that Chile's intensity are larger than in Japan, except for buses, which makes a lot of sense with the relatively large share of activity from this vehicle type. It would be interesting to track down the policy choices that led to such different shares. Note that on the right-hand side, I also show for your information the carbon intensities, that is the emissions per PKM. It allows to track the most carbon efficient modes and to see the indirect impact of the electricity production mix, for instance. Okay, so let's move on to the Menti. So what represents a good measure of activity in the transport sector? Either PKM, TKM, vehicle kilometers, the stock of vehicles, or the load factor. I think you can answer several questions here if you want. No, you can't. My bad. Let's say, what will be your priority in terms of collecting data? Let's put it that way. See, PKM is the priority. I guess it comes from the policy priority that you expressed before on this segment in your country. I also see the stock of vehicles that can be interesting with respect to the age of the fleet and how quickly it is replaced. It is often a priority in countries where the industry is big as well, as there might be policy entanglement between industry and transport. And I see vehicle kilometers. The good thing with vehicle kilometers is that it relates a lot to infrastructure as well, and it is cross segments. It is sometimes hard to use the vehicle kilometers only. Okay, in the interest of time, I'll go to the next. Small hands-on calculation exercise. Let's say that we did this workshop in person in Mumbai, and at the end of the workshop, we went to get a few souvenirs for the group. We actually got a lot of it, say 200 kilos of souvenirs for the group, and we moved from our visit in the gateway of India to the train station, which is 2.5 kilometers away. So let's compute the passenger kilometers, the ton kilometers, and the vehicle kilometers in this scenario. So as all answers are different, maybe you can compute one of them and find the right answer. So here you have different ways of computing this. Either you take the average load factor, for instance, or you can sum up the travels of everybody. So there's a clear edge for the second answer. Let's maybe take the example of, let's compute VKM. So we have two vehicles here, one bus and one boat, and they both do 2.5 kilometers. So each of them represents 2.5 vehicle kilometer. So the sum of it is 5 vehicle kilometers. And if we look at the passenger side of it, let's use the method where we do the average load factor. So we have one vehicle with 4 passengers, one vehicle with 2 passengers. That's an average of 3. And we multiply by the sum of the kilometers. So one vehicle did 2.5, the other did 2.5. That's 5. So 3 times 5 is 15. So it's indeed the second answer. I'll let you do the TKM version at your own pace. Okay, another interesting question is with this graph. This graph shows for 3 years. I took data before COVID because obviously it has a big impact. It's indicators with index 1 into the 2017, just for the exercise. It's for bus transport, and the energy intensity in dark blue, it worsened. That means it increased. We need more energy to do the same service. And it gives the fuel intensity in light blue and the occupancy in green. Okay, and for this, we would like to understand why the energy intensity of the bus transport worsened during the period. What can be the main reason for this trend based on the data that we provide? Okay, I see a first answer already. I'll give you a minute and a half maybe to think about this. Actually, I'd be interested if anyone who answered or who is thinking about it wants to do this live, wants to take the floor. I don't know if we can see that on the chat. Feel free to raise your hand. I think that'd be interesting to hear you explaining the reasoning that goes behind it. Okay, so most answers are about lower occupancy. I don't know if anyone sees someone wants to raise their hand. So right. Mostly it's lower occupancy. What we can see is the fuel intensity in light blue decrease. That means that we consume less energy for the bus itself to travel, right? So the energy intensity we could have thought would decrease as well. But if you reduce the number of people within that bus, it kind of travel for nothing if we put it to the maximum just for the sake of understanding the reasoning. Let's say the bus travels empty, then the energy intensity per PKM would go to infinite because the PKM itself would be 0 even if the bus travels, right? So that's why the energy intensity per PKM increases. It's very interesting, this exercise, because it shows the importance of choosing and interpreting correctly all the different indicators. A last question for this part, what contributes to efficiency in the transport sector? So we have a lot of different things that can contribute to efficiency in the transport sector. Maybe you want to think about a couple of those. We see mass transport, fuel switching, ride hailing, technological innovation. I guess by this you mean purely the engine being more efficient, higher occupancy in the vehicle. Yes, more efficient vehicles. Digitalization. I'd be interested if the person who wrote that could maybe put something in the chat box to give more details. So clean electricity would probably contribute to carbon efficiency, not so much to energy efficiency. But it's true that electric vehicles are in themselves more efficient in energy terms than, say, internal combustion engines. Route design is an interesting one. Indeed, you would probably reduce the amount of energy spent in traffic jams. Fuel quality is also an interesting one. Harder to track though. Excellent. Thanks. That's a lot of very nice answers. In the interest of time, let's move on. So let's look at the methods for collecting data. There are numbers of ways to collect the data. We can first look at low-hanging fruit. We find a lot of informations and data from administrative sources, which become a basis for many data and are often already gathered by other institutions. What might be difficult is the communication between the different data sets. Secondly, we can perform a well-designed survey, which is costly but very effective and can be done every X years, maybe 3 or 5 years. Thirdly, with the infrastructure implemented, we can directly measure necessary information. It requires specific equipment in the first place, but is very valuable data. And lastly, we can do a modeling that uses all these available sources and certain assumptions to resolve the data gaps. It requires robust input to produce nice and robust outputs. With all these pros and cons, we would like to suggest you first to have a look at what data may be available in other institutions, in other ministries, and how to complete existing data collection before setting any new one to save the resources. Transport sector is quite complex. It includes reporting from enterprises that provide passenger and freight transport services, from passenger and freight transport in other sectors and in households. The National Vehicle Register can be used as a base for the transport sector statistics to derive the fleet with the vintage. The data collection and processing in National Statistic Office in the Department of Transport can be organized to communicate correctly and have the same boundaries in all the data sets. Very important in terms of methodology. And the basic annual statistics on passenger and freight transportation can be taken a lot from different enterprises, as it is often collected every year from maybe tax declaration or revenue declaration. And it can be then completed with scheduled surveys or data collection from other sectors. Some countries conduct mode-specific surveys to the service providers. Here we have an example with the rail, as it is organized by often large enough companies. Both the activity and the energy consumption can be reported somehow easily, as it is often data that the companies collect anyway. The important here would be the focus on clear and transparent institutional arrangements and legislations for this data manipulation. Some modes are more difficult as the number of stakeholders is significantly larger. For passenger private road transport, that is cars, motorcycles, and 2-3-wheelers, survey data can be collected either through specific transport-only surveys or through the household surveys that often exist already and are conducted every maybe 3 or 5 years. It would also allow more clearly, as I explained at the beginning, to disentangle the part which is actually transport and the part which is maybe allocated initially to households, but actually is, find the right boundaries between these two sectors. Information on activity and consumption can be collected on the expenditure, which can be transformed into consumption, as well as on stock, distance travel, and that can be transformed into VKM and PKM. They would often be completed with administrative data. It can be from registration data, as I said, or the mileage. It can also be from maintenance data. That happens in some countries that they collect the data at the maintenance level, which is often mandatory. So then this provides data which is a lot more regular and a lot more accurate than when taken every 3 or 5 years. And then it can be completed with, as I said, estimations and modeling tools. One last set of questions, which I hope would open up also on the discussion for the policies. Do you collect detailed data split by vehicle type in your country? Maybe you know of specific data collections, whether, as I said, administrative sources, surveys, and so on. Okay, we see a mix. Activity data seems to be more on the non-collected side. Due to the information from setting points, sometimes the energy consumption data is easier. This is something that we see in a lot of countries. I want to stress that pretty much every country struggles with this type of data. This is very disaggregated, and to get some interesting information, it requires continuous resources allocated to it and strong policy will. Okay, I don't see it moving anymore, so I'll switch to the next. How do you collect energy consumption data split by vehicle type in your country? So here, just the energy side. Maybe you already have some insight of how it's collected. Yeah, gas station is often the basis. What is very difficult, I don't know if you can answer or complete in the chat box, is gas stations don't tell you necessarily if they provide diesel for a personal car, a van, a truck, a three-wheeler, a taxi service. So it's difficult to disentangle the different modes and the different segments and vehicle types. National survey, registration from the Bureau of Transportation, I like this one, means that the data exists somewhere. It's more like the data flow from one institution to the next. Household energy consumption survey, same. Excellent. Maybe one more minute, and you can start thinking. The next question is the same about activity data. But I see fuel, gas stations and surveys are the most recurring ones. In the interest of time, let's move to the next one. So for the activity data, how data is collected split by vehicle type. Okay, so I see 2 dedicated surveys. It'd be interesting to see if these surveys are focused more on the freight segment or on the passenger segment. Okay, surveying mostly. Registration data. Yes, I like that. Again, it needs a bit of estimating to transform the new registration into the stock. No collection. Thanks for answering that. City authorities. I like that. Very interesting. It means that indeed there's data that comes from different levels of administration, and it needs some federal or national organization so that the data flows from these local institutions to maybe the Department of Transport. One thing that maybe you can also answer later, I'll let you think about it. I'll leave that one open. What would be the most difficult for your institution or your country to collect, whether in the industry, in the energy or in the activity transport data? What would be the most difficult to collect? That's very interesting because we want to know what is difficult for you to be able to provide the best advice and the best examples, maybe from other countries which have done that, maybe to assist you on collecting this data if the will is there. I'll leave that one open if you want. Let's finish off with the IEA tools actually for data capacity development. So as we mentioned the other days, and as I want to stress again, we have this National Data Collection Practices database that gives a lot of examples from a lot of different countries, whether on transport, industry, any sector you want, any methodology we want. What I find very interesting in this database is that you have often examples like the survey, the questions they actually asked, the feedback, that means what type of difficulties they've had, what kind of perks they saw in doing that. And also we can easily put you in contact with the people who have done it. So they would have even more, tailored feedback to provide you depending on how they done it. And sometimes you can see the surveying might be a bit old, but you might know that this is done every 5 years. So they might have done a second or a third leg of the same surveying. It's very interesting to have this type of feedback on longer term. I also want to stress these two manuals, the Fundamental on Statistics and the Essential for Policymakers. They both provide a lot of guidance and a lot of examples on how to collect this type of data, what we can learn from it. And we have the e-learning platform on these topics. And finally, we have this newer guidebook that is about designing an energy statistic roadmap that is very interesting and is developed to support the different countries in the development of their own national roadmaps to strengthen their own energy data capacity. It has a lot of description of the key components of the energy data systems, as well as recommendation that you can maybe pass on to the different other institutions to strengthen all these. And to conclude, we saw again that the energy demand and end-use data provides a detailed breakdown of energy consumption going beyond the sectoral level data to subsectoral vehicle type consumption. It allows for a precise energy demand analysis. Energy demand and end-use data enhances the policy effectiveness and decision-making. With granular demand-side data, policymakers can tailor the energy policies to specific end uses, set realistic targets, and also track the impact of each of the regulations with respect to each of these targets. The reliable data allows policymakers to assess, set, and monitor the targets for energy savings, emission reductions, and overall the system's performance improvements, including the supply side. Energy demand and end-use data also improves the accuracy of energy modeling and forecasting. Sectoral averages can mask some critical variations in energy use, as we saw in the decomposition analysis. Detailed end-use data ensure more reliable bottom-up modeling, improving the demand forecasting, the scenario planning, as well for the infrastructure. The detailed consumption data is essential for bottom-up modeling, which enables accurate demand forecasting. And finally, the energy demand and end-use data supports targeted energy efficiency measures. End-use data helps identify which technologies and which processes drive the energy consumption within the specific subsectors or segments. It enables more effective efficiency improvements, and it helps track improvements to evaluate the policies and set, again, achievable targets. With collecting and analyzing subsectoral and end-use energy demand data, countries and industries can design precise, impactful strategies hand in hand to reduce their emissions, enhance their efficiency, and drive the clean energy transition. And with all this in mind, I thank you all very much, and I pass on the mic back to Natalie.
Thank you very much, Thomas, for what was a very both insightful and engaging presentation. It was really nice to see a lot of responses, and some of those questions were a bit challenging. I didn't know we'd have to do math today, so I hope that everyone enjoyed that, and on a Thursday afternoon, it kept people quite engaged. So now we'd like to look at a little bit more on the side of data and energy efficiency indicators, and I'm going to invite from APAC, Edito Barcelona, who will give us another presentation. Thank you, Edito.
Thank you very much, Natalie. I'm now sharing my presentation. Is it now in slide mode? Almost. Okay. Yeah. So I will be presenting the transport demand data and efficiency indicators in the Southeast Asia's transport sector. So these are the contents of my presentation: the transport energy consumption data of Southeast Asian economies, transport activity data of the same economies, energy indicators, and conclusions. My slide is not moving. But anyway, for the transportation data, I'm only presenting the data of 7 Southeast Asian economies: Brunei Darussalam, Indonesia, Malaysia. It's not appearing. Okay. Philippines, Thailand, and Vietnam. My slide now is in Brunei Darussalam, and I'm showing the transport energy data of Brunei, which is disaggregated into domestic air, road, rail, domestic air and road transport. They have data for these 2 subsectors of the transport sector. And I'm also showing the data on bunkers because for some economies, I think bunkers data are included in domestic air and domestic navigation. So the next slide is Indonesia. They don't have data on international aviation and marine bunkers. I suspect that maybe some of the domestic air consumption might be for international aviation bunkers, but for domestic navigation, the data is very small, so I don't think marine bunkers is included there. And for Malaysia, they can report international marine bunker, but not international aviation. So I'm afraid that domestic air includes international aviation bunkers. And for the Philippines, the bunkers are there. So I believe the domestic air and domestic navigation data are okay. And for Singapore, it looks like it's also okay. Thailand has international aviation data in our energy balance, but they don't have international marine bunkers. Although, if we look at their publication in page 28 of the energy balance of Thailand, I saw data on international marine bunkers. So maybe next revision cycle, Thailand's international domestic navigation data will not include international marine bunkers. So I'm showing this because this will affect the indicators that are calculated later in the presentation. And this is Vietnam, also not able to report international bunkers. So I worry that both domestic air and domestic navigation include bunkers. As for transport activity data, so there are not much transport activity data in APEC, although we have gross domestic product, because we know that when the gross domestic product is increasing, we think that transportation consumption would also increase. And the next activity data would be population, because we know that the population increases, the energy consumption in the transportation sector might also increase. And the next energy activity data is number of road vehicles. So the slides that I've been showing there are parts that are highlighted in yellow. Those are the 7 Southeast Asian economies that are also members of APEC. So for number of road vehicles, this includes motorcycles, passenger cars, buses, trucks, and motorcycles. The slide's quite slow. I'm now on the number of road vehicles slide. And my next slide is data on road passenger kilometer for the 7 economies, Southeast Asian economies only. Vietnam has data on passenger kilometer, but only from the years 2000 to 2004. And for now the slide caught up, but not yet, still late by a slide. And the next one is road passenger kilometers. Vietnam also has some data. No, this is ton kilometers. And next is, okay, about passenger kilometer. What is a passenger kilometer? This is a unit of measurement representing the transport of one passenger over a distance of 1 kilometer. It is a way to quantify the amount of passenger travel within a transport system. So, and I have a question to participants. Based on your daily commute to work, approximately how many kilometers do you travel each day on average? So I have an answer. I will not, you cannot put your answer in Menti, but I have my answer. For me, I travel 42.8 kilometers per day. That is round trip from my home to the office. So if I multiply it with the number of working days, I might be traveling for 11,000 passenger kilometer in 1 year. So, but I take the train. So I think my transportation is very efficient. My answer, it's there. 11,000 passenger kilometers in 1 year. That's for me. And so for you, based on your daily commute to work, you can calculate how many passenger kilometers do you have in 1 year. Okay. So next slide is this one. I want you to calculate how many passenger kilometers for a bus with 40 passengers that traveled for 10 kilometers. So how many passenger kilometers would that be? So that would be 400 passenger kilometers. And for a motorcycle with 1 passenger traveling 10 kilometers, that would be 10 passenger kilometers. And for a car with 4 passengers traveling 10 kilometers, that would be 40 passenger kilometers. And for a train with 100 passengers traveling at 10 kilometers, that would be 1,000 passenger kilometers. Okay, so that's how you calculate passenger kilometers. So when you conduct a survey, you can ask the people's average travel per day, and then you can calculate how many passenger kilometers in a year. Now, My next slide, how about this? How many passenger kilometers? You don't have to answer. This is just being shown as to make you smile. Okay. Next slide is about road freight in ton kilometers. So of the 7 Southeast Asian economies, only Vietnam has data, but only until 2004. And a ton kilometer is a unit of measurement used in freight transport to quantify the amount of goods moved. So that means 1 ton of good moving for 1 kilometer is 1 ton kilometer. Okay. Next is for rail. This is similar, but for rail, Vietnam also has data until 2004, but all the other, and Thailand too has some data. So now I'm going to energy indicators calculated. I'm going to show energy indicators calculated from this energy and activity data. Okay, so the first energy indicator is energy consumption per, what is this? Per unit of gas. Energy indicators per capita in the transportation sector. So this is total energy consumption divided by population. We can see Brunei is at the top. Although I put an asterisk for Indonesia, Malaysia, and Thailand and Vietnam, because as I've said earlier, I worry that some of the bunkers data are included in the domestic transportation. So, and for energy consumption per capita in domestic air transport. So I also put asterisks for Indonesia, Malaysia, and Vietnam because they are not reporting international aviation bunkers. So whatever is calculated there would not be might not be accurate data. So, and then there seems to be data error in Vietnam's 2014 data. Now, the next slide is energy consumption in transportation per unit of GDP. Again, I have asterisks for Indonesia, Malaysia, Thailand, and Vietnam. And so that means that whatever is calculated there is sort of might be bigger than the actual data because of international bunkers being part of the domestic consumption. And the next one is energy consumption per road vehicle. Now, no more asterisks because they can report road vehicle data, energy consumption in road transport, and also number of road vehicles. Vietnam here has the lowest consumption per vehicle, and that is because more than 90% of road vehicles in Vietnam are motorcycles. And there is also a data error in 2014. You can see the dip there. And as a conclusion, those are the only indicators that I could calculate because of the lack of data. So as a conclusion, international bunkers, marine aviation should be separated from final consumption of the transport sector. And transport energy consumption should be broken down by mode, air, road, rail, water, pipeline, and others. And a lot of data are needed that are not compiled in energy balances. The first 2 bullets that I mentioned, you can find in the energy balances. But there are data that are beyond the energy balances, like energy consumption per passenger transport per type of vehicle, energy consumption per freight transport per type of vehicle. And to have good transport energy efficiency indicators, the following data are needed. Number of vehicles by type, and like cars, light trucks, buses, trucks, and motorcycles. And transport activity data such as passenger kilometers, freight ton kilometers, per transport mode, and per vehicle type. So that's my presentation. Thank you very much.
Thank you very much. That was a great presentation looking at some of the more specifics of the region. Now we're going to look at a country presentation. So we've had the opportunity to look at some of the countries in ASEAN, and now we'll have the opportunity to hear from someone from India. So we have Deepshika Wadhwa, who is a senior sector expert from the Bureau of Energy Efficiency from India. Are you able to share your slides? Okay, while we wait for them to share their slides, I'd like to call on my colleagues from the Energy Data team because we have a Q&A here discussing methods for data collection and country submissions. Would you be able to answer the question from our Q&A?
Yes. Sorry. Yes. So the question refers to countries' own formats and methodologies. And well, I would like to point maybe 2 points on this topic. The first one is the benefit of using the international standards and aligning the data dissemination with these international methodologies is that first, you don't really have to reinvent the wheel, and it allows a lot of comparability with other countries, as well as a lot of ability for the international institutions that produce these methodologies hand in hand with a lot of different experts from a lot of different countries to assist you in these data collections. And the second point I want to stress is that it allows countries to actually improve that disaggregation by taking the advice of also a lot of different countries because they use the same type of methodology, the same type of disaggregation, and so on. There's actually a lot of efforts being put into making these methodologies as clearly and as updated as possible from people from all around the world most often. So should you wish to have also your inputs in these methodologies, feel free to do so. And the last point I want to say is these methodologies and disaggregations are very often updated. So hopefully they keep track of the changes in the world that we see, whether it's, new fuels for aviation, it's as quickly as possible included in these methodologies. I hope I answered the question. Thank you.
Thank you so much, Thomas. I see Aditya has raised your hand. Please go ahead.
It was just wanted to say that the Indian panelist is not in the panel, so maybe that's why he cannot share his presentation. But Matthew said he's already there. So sorry.
Yes, no worries. Are you able to share your slides now? Okay, while we wait, we'll open up to any more questions here. Does anyone have any other questions they'd like to ask? I see our panelist has joined. Are you able to share your slides? Okay, while we wait for our next panelist to share their slides, Thomas, could you explain a little bit more what's the importance of looking at passenger versus freight data? We had a question about that as well.
you hear me? Can you hear me and see me? We have some technical difficulties as well here.
Yes, thank you, Agnieszka. I think we're having technical difficulties on a couple of sides here.
I understood you were asking what's the difference between passenger and why it's useful to distinguish between passenger and freight transport, right? Well, for us, when we are looking at energy efficiency indicators, it's usually the first breakdown which we do for transport information. It's simply because both these modes, they have very different motivation, organization, and drivers, and therefore should be useful to examine them separately. And thanks to this separation, we can build meaningful indicators. I think I see our panelists now, so I'm giving back floor to you, Natalie, if you don't have any.
Thank you so much. So we would like to turn the floor over now to Deepshika Onwa, who will be presenting from the Bureau of Energy Efficiency, looking at the experience from India. Are you able to share your slides now?
Yeah, thank you for giving me this platform. So, Rennie, are you sharing the slides or shall I share it from my side?
Yes, if you wanted to just share on your end.
Yeah, happy for you to share if that's easy. But if you prefer us to share the slides, let us know.
Okay, let me share that.
Deepshika, if you would like me to share the slides, I'm very happy to. It's no trouble at all.
Yeah, you can share.
Okay, let's see if.
Thank you.
Let me just put this here. There we go. Now, can everybody see those?
Yeah, it's
slides
visible.
okay? Are you seeing the right thing, or should I swap the? Is that correct?
Can you move to the starting one?
Right.
Yeah. Thank you.
Are you seeing the correct view without the notes? Yes.
Yeah.
Wonderful. Okay, I'll mute myself. Thank you very much.
Thank you. So, to start with, once again, thank you. Regarding the Energy Data Management Unit for India, so it was established in the year 2022 with the objective of collecting the data both for the supply side and the demand side. So, next, please. So, there was a need for this Energy Data Management Unit with an objective that there was no other government publication till the year 2022 which was able to capture both the supply and demand side data and what are the actual gaps that are lying between these two. So for the reliable and comprehensive energy data management, this unit was established under the directions of Ministry of Power. So the key objective was once again to meet the India's updated NDC, that is to reduce the emissions, to increase the installed power capacity with the non-fossil sources, and to achieve the net zero goals. So with all this intent, we started with this energy data collection since the year 2022. So as if I talk about the journey so far, so next please. Under this Energy Data Management Unit, we have the hierarchies like the Secretary is the chair, Secretary Minister of Power chairs the meeting, and below that comes the Director General Bureau of Energy Efficiency who convenes the meeting. And we have representatives from various line ministries and departments comprising of the NITI Aayog, Ministry of Coal, Ministry of New and Renewable Energy. So each ministry is responsible for submitting the data to BEE pertaining to their division. So like road transport and highways, because this session is focusing on the transport. So here we are dealing with the Ministry of Road Transport and Highways in India, who actually captures the entire database for the vehicles, freights, aviation, ship, all this. So next, please. This is the journey so far in the EDMU. That is, it started in the year 2022 and till the year 23 for the release of the first publication, we conducted the sixth steering committee meetings. And we came up with the first publication in the year 2023 that the data was for the year 21-22. And the key insight of this report was it comprised of the realistic coal supply and consumption data. And recently, in the year 2025, we came up with the next publication, the second edition of the India Energy Scenario Report, which provided the detailed insights into the overall Indian energy landscape. So this is the overview of the energy balance highlights that was we were able to capture in this second edition. The left side shows the primary energy supply data, the input side, and the right side shows the overall demand side data that we were able to capture. And it was the total 597 MTOE consumption was recorded, amongst which 12% of this 597 was under the transport sector. So this 597 has been segregated across sectors, industries, key sectors, that is industries, transport, residential, commercial, and agriculture, and the non-energy, that is the non-specified. So in the upcoming publications, we will be working on this others category, that is 18%, which is not yet identified that to which sector it is going. So we are working to get the breakdown of this others category, that is a non-specified category. Next. So, as this workshop today focuses on the collection of the demand side data, so I have prepared this particular slide that is focusing only on the demand side analysis. So now, if we talk about the transport sector, we have bifurcated this transport sector data across road transport, railways, shipping, and aviation. For the road transport, these are the indicators which we have captured in our report. That is, for the road, we have captured the passenger and freight in kilometers, that is the distance traveled, and how many vehicles have been registered that we gathered according to the Vahan database that is maintained in India, and how much we are adopting the EV, how better we are moving towards the EV penetration. And then the next one is for the shipping, where again we are capturing the freight in kilometers and the fuel consumption, and again for the aviation. So next, in the next slides, I'll be showing the insights of the transport sector. That is, this particular slide displays the 72 MTOE consumption in the transport sector that was due to the fuels, oil, gas, and electricity. Electricity basically shows the electrification of this sector, that is the penetration of EVs, and how much electrification has been improved in the railway sectors also. Next. So this is the sector-wise energy consumption in the transport sector across like different segments, like the road transport majorly contributes to 76.3% of the 72 MTOE, and followed by the domestic aviation and the railway sector. Next. So these are ideally what happens in India also. Different type of transport are being handled by the different ministries. Like the Ministry of Port and Shipping is responsible for providing the shipping related data. Ministry of Aviation is responsible for providing the data related to the transport segment for the aviation. And then likewise for the railways, there is separate ministry, the Ministry of Railways. But this energy data management unit is consolidating the data from each of the ministries, from each of the departments, and the entire data set is represented in the India Energy Scenario Report. And the balancing is also done where the gaps are there. How much was the supply and how much is the consumption? So where the gap actually lies, as I mentioned in the previous slides, that we are now working on identifying the non-specified data, which is actually not captured, that where that coal, fuel, oil is going into which sector, because that bifurcation is not actually we were not able to capture. Although we were able to reduce this non-specified segment from 26% to 18%, but yes, the gap even now lies. So we are working on that. We're conducting certain surveys under the various sectors. So we aim at filling this gap in the upcoming versions. So this is a complete journey of how the transport policies in India have is progressing since the year 2006 until the year 2023. Under this, CAFE norms comes under the purview of PEE, that is the corporate average fuel economy norms that were laid for the passenger cars, the road transport passenger cars. Next. So this is the quick insights of the demand side data for the transport sector, that there is a high surge in the energy consumption since the year 2014 to 2024, that it is almost doubled from 35 MTOE to 72 MTOE. And the road transport, this has already been submitted by me, that it is alone contributing to 76% of the entire energy consumption. And next, the petrol consumption is again rising from 23 to 37, but this is not that much because of the adoption of the EVs. So EV registration has risen from 0.3% to 7% in last 10 years, around 7 to 8 years. And next is the electricity consumption for FY24 stands at 33 terawatt hour compared to 16. This rise is because of the adoption of the electric vehicles and the electrification of the BG network for the railways. Next. This is a quick overview of the picture of this, how EV registrations have been increased from the year 2016, 17 to 23, 24, and how much electrified and non-electrified network routes lie at present in India, if we compare it with the year 2010-11. Next. And this slide basically depicts the impact of the energy efficiency measures that India has taken across various sectors, and they all in collection contribute to this achieving this energy savings of 53.6 MTOE, wherein the orange line depicts the BAU scenario. That is, if no policies were there in place, then it was expected that 650 MTOE consumption would have been there. But due to the intervention of the energy efficiency measures, we were able to reduce the 650 MTOE BAU consumption to the actual consumption of 597 MTOE. So we were able to achieve this 53.6 MTOE savings during the year 23-24. So this was the entire demand side analysis that has been captured in the India Energy Scenario Report. Further, if you would like to have an idea of the different sectoral transport consumption, like what has been the consumption in the shipping sector and the aviation, then the detailed report that is available on our website, or I can also share the link, can be accessed. So that's all from our side. Thank you so much.
Thank you so much for that very insightful presentation. And it was great to make the link on the non-specified data, which is something we mentioned earlier in the week when we looked at industry. Also very impressive to see some of these electric vehicle registrations in India. It's quite an impressive growth rate. So now we'd like to kind of wrap up the session, and I wanted to take an opportunity to thank all of our speakers and panelists who've been here over today as well as over the last 3 days to give us both country insights as well as regional ones, and to look a little bit at that global aspect as well. So we started the week off looking at industry, and one of the things that we also had in the presentation just now was looking at the importance of disaggregated data and also looking at non-specified data. And I think, Toma, you had a slide that you wanted to show here where we could look at the importance of non-specified data. So So here, this slide, we're looking at, we'd mentioned this on the day one, that industry covers a wide diversity of subsectors, and this obviously is relevant for any subsector. But what's really striking about this, and I wanted to summarize here for you, is looking at this orange bar. So the orange bar, if you see in the bottom at the right, that's non-specified data. And here we have across kind of Southeast Asia and a couple of the surrounding countries, looking at how big that orange bar is. And we see, especially further, the countries further on the right-hand side here, have a very, very large percentage of the energy consumption by industry subsector, which is in the non-specified category. That means that we actually don't know how the energy consumption is disaggregated across subsectors. This is also something that the IEA can maybe support on. If you see your country on that list and you think that the orange bar in your country is very high, and that's just for industry, of course, this chart, but that's just to kind of give a flavor here. We see that in the region, there's countries that have a much larger orange bar than the global average there, which is about 20%. And so this is maybe a lack of data collection, or maybe it's a lack of information about the data collection here. And this is something that we'd be happy to work with countries on if you're interested to maybe do some data collaboration or exchange, and also to help look at how you could collect more data to help fill in the gaps here. And we've seen kind of how important this data disaggregation is. And I see a hand here. Yes, go ahead.
Yeah, so I had point to submit here. That is that in the India, specifically for the industry sector, by the virtue of the second edition of India Energy Scenario Report, we were able to reduce this industry non-specified gap to 6% through the PAT related data. That is the data we captured through the Perform, Achieve, and Trade scheme in India we are running. So we were able to reduce this gap by 6%. So we're still working on it to uh, reduce the gap more.
So you reduced it by 6%, is that correct?
Yeah, yeah.
Okay, that's wonderful, and it's great to hear. The Perform, Achieve, Trade is a very interesting and very impressive policy kind of framework that's been done in India, which we've mentioned in a few of the IEA reports and training, but something that people, if they're interested to know more, they can reach out as well. So I just wanted to show that chart and show that in the region, there's some work to be done on filling in those data gaps, and it's really important here. And we could probably show that, or maybe Toma would be able to show that if we asked maybe later on different subsectors. And if you're interested to know more for your country on different aspects here, we can talk to you individually about that. So going back to the kind of overarching view of the training, I think it's been really good. We had, I feel like I learned something. And, we also had buildings where we looked at space cooling is very important. I'm here in Singapore, 30 plus every single day. Obviously, space cooling is hugely important for the region, and looking at the impact of that both today and moving forward will be quite important in particular. So making sure we have good disaggregated data there. Transport, we're looking at measuring something that's sometimes a literal moving target. And so there were some interesting points that Toma brought up today about if things are moving across borders and how do you track that data? So it's a little bit more complicated to track across borders. And how can you categorize that data? And so this is an area where having cross-border exchange is really interesting, and especially in the Southeast Asia region, we know there's a lot of work going on cross-border exchange. So now I wanted to let you know about some of the other things going on at the IEA. We have some other training. So we're going to be having in October a global data training, which will be provided by the same team if you want to dig more into this work. We also have, this is going to be happening at the end of June, the Regional Cooperation Center here in Singapore. We're hosting a training online about nuclear in ASEAN. This is the topic that's become more popular. We also have in October in person in Hanoi, we'll be hosting the Energy Efficiency Training Week, as Renee mentioned earlier on, and that'll be for Southeast Asia, a 4-day online course with 5 different concurrent courses, including one on indicators and evaluation, as well as one on transport. We also have a variety of online self-paced training that you can do on the IEA website online anytime, including ones on statistics and statistics for policymakers. And then, of course, there's other opportunities for you to engage with us. So, for example, we've mentioned here if there's bilateral work you'd like to do with the IEA, this could include looking at methodological assistance or any kind of data exchange, and also to help with data validation. We have previously done bilateral, very specific training with different countries. So if you have a request, you want to know some specific indicator, how we can support you in developing work around that, or you have some specific data need, you can ask us, and subject to our own capacity, we might be able to provide a kind of a more bespoke training for your specific country. And then if we also have some bilateral work. So as I mentioned, I work in the IEA's Regional Cooperation Center in Southeast Asia, and we're looking to expand our both bilateral and regional work. And we have a few different areas that we're working on. Other than doing capacity building like this, we're also working on power systems, renewables, finance and investment, as well as energy technology. And so we're looking forward to that, and we'll put in the chat here a couple of email addresses you can contact us at. And I see there's one hand, so Aditya, go ahead.
Thank you very much, Natalie. I would like to announce to the Southeast Asian participants, Southeast Asian participants who are also from APEC. So that means Myanmar, Cambodia, and Laos, not included. Sorry. We will hold the 23rd APEC workshop on energy statistics in September, on 17 to 19 September. And our topic would be developing household energy consumption survey instruments. So, during this workshop, we plan to produce a questionnaire for household energy consumption survey. And then we will request participants in the workshop to pilot test the questionnaire in their economies. And then this result of the pilot test will be reported in the next workshop. So probably in 2027, the pilot survey to be held in 2026. So that's it. I invite Brunei, Malaysia, Indonesia, Singapore, Thailand, and Vietnam, and the Philippines to please come to Tokyo and participate in this workshop. Thank you very much.
Thank you so much, Aditya. So another opportunity for some great capacity building and exchange. And there's been some questions about whether we will share the presentations. We will be posting online, subject to confirmation from all of the speakers that they accept. We'll be posting online on the IEA.org website, all of the presentations as well as the agenda for today. So you can find that. We'll be posting that quite soon. Okay, are there any other questions before we wrap up? Okay, seeing none, thank you everyone. This was a wonderful opportunity to exchange, and we look forward to hearing from you again. Oh, go ahead, sorry.
I would just like to say that we allow our presentations to be posted in that website. So please share.
Perfect.
Thank you very much.
So we'll have quite a few presentations on there. Thank you so much. And thank you to the rest of the team at the IEA, as well as to our other speakers from APEC and from countries as well that we had throughout the week. That was wonderful. And thank you to the Bureau of Energy Efficiency for presenting as well. All right, have a wonderful afternoon or morning, everyone. Goodbye.
Thank you very much.
Bye-bye.
Good to see you, everyone.
Thank you.